Welcome. It's a pleasure to have this workshop here as part of the AADE conference. My name is Eran Atlas. I'm the CEO of Dream Diabetes. And this morning we're going to give you some tips about how to run a digital clinic, how to analyze data with CGM, and how to use some artificial intelligence as part of this process. So with great pleasure, I'm happy to invite Dr. Gregory Florenza from Barbara Davis to give the first presentation.
Okay. So good morning. My name is Greg Florenza. I'm a pediatric endocrinologist at, I'll move this up a little bit. I'm a pediatric endocrinologist at Barbara Davis Center in Denver, Colorado, and I'm going to be talking to you guys today about the ideas behind running a digital health clinic. And this timer's not working, so I'm just going to get my own going. And I always want to start with my disclosures. So I do work with every company in the US that does any kind of commercial diabetes products: Medtronic, Dexcom, Abbott, Tandem, Insulet, and Lilly. And so I always say I'm probably one of the most conflicted speakers that presents, but I actually think that that's a good thing because we get to see what's coming from all these companies and also what they have in common and what needs are there. And the main theme of today's talk is actually a huge need that is still there, which is that with any of these technologies, as you're getting information in and delivering care through them, we need to have some intelligent way of doing that. So the three topic areas I'm going to talk about are data visualization, clinical flow for digital clinic, and use and visualization of the data in clinic. So the first key to a digital clinic, I think, is to visualize the correct device data. And this is something that, as many of us know, can be very challenging. I run a telemedicine clinic in Denver that's about 4 hours away and 2 mountain passes away. So there are times of year where our patients can't even get to us if they want to. And being able to still have the same quality of care with me in Denver and them in Grand Junction is a very important part of that relationship. The same applies to, tuning patients when they go back to school or when they have major lifestyle changes. And the first key to that is actually getting the digital data. I create a walkthrough for our clinics about that. And what I've gotten for the current commercial devices is that you basically need 4 to 6 cables in order to download everything. And that can be challenging if you don't have control over what's going on at the site. Additionally, a big issue that we run into with our digital clinics is computer ownership. It sounds like it's kind of trivial, but if the hospital owns the computers and you don't have administrator access to them, you can't update the flash driver, you can't update the USB drivers, you can't update the Tide Pool or the Gluco uploader. And those are things that, if you think about starting a digital clinic somewhere where you don't already have one, or making the clinic that you have more robust from digital architecture, those become very important, is having the right cables, having the right drivers. And that can be the thing that keeps this from happening at a lot of sites. So despite me opening with that, I hope that it will become a non-issue in the near future. Most of our devices are moving towards perpetual connectivity. An example of that right now is Dexcom G6 and G5, which, if the patient has clarity on their phone, just goes straight up to the cloud. It becomes necessary to have an administrator account that's then linked with the Dexcom account so that you can just get the data. But for most of my patients, they don't even have to do anything. They just email me and they say, Dr. Florenza, can you review my CGM tracing and give me dosing recommendations? And once we have that set up once, we can just do that perpetually. And the same thing for our digital and outreach clinics, patients in college, patients at external sites, they're able to just get that. Medtronic, Tandem will be bringing those out in the next year, and Insulet, that's now available with the Dash product. So this is a good slide that I think is a useful resource as someone is thinking about, expanding their digital architecture or expanding their use of a digital clinic, which is what works with what. I like theoretical discussions, but this is, I think, a very practical discussion, which is if we're going to start using Tide Pool in our clinic or we're going to start using Gluco in our clinic, what can we use as a uniform interface? And so here's an example from Thomas Dana, who in those slides earlier, he was I believe the bottom right picture, who's going to be doing some educational sessions online. But this is the current consensus for uniform presentation of data, which I think is the main thing that a digital clinic needs once you have the data in there, is uniform presentation of data. To some people, this is something they've heard about for many years. To some people, this may be something relatively new. And the idea is that when you get an EKG, you don't ask the question, who built the EKG machine? None of us even know probably who makes most EKG machines. Every EKG printout looks the same. And that's what we're trying to go to with digital diabetes data, is to have a similar presentation of data. And this paper that I'm citing here by Thomas Dana is a consensus of consensus of consensuses. And so it's taken us a long time to arrive at agreeing upon what this consensus presentation can be, but we're finally getting there. The main point in that is agreeing on a standard metric, which is time and range. Time and range is something that I think about a year and a half ago was a pretty esoteric topic. Hopefully now it's something that you're hearing about multiple times this week. And the consensus time and range that we're moving all of our clinics to, and that hopefully everyone is moving to, is 70 to 180 milligrams per deciliter, or 3.9 to 10 millimole. I show the millimole values for two reasons. One, a lot of international audiences prefer that, even though to me it's weird. It's like a foreign language. I can't think in millimoles. But the other reason is that's part of the consensus. Why did we pick 180? Because it's 10 millimole. There's a little bit more to it than that, but that's the basic idea. Why do we have weird metrics like 54? It's because it's 3 millimole. We had to compromise on who would get round numbers when. And just little things like that, I think, can help us realize, oh, that's why these things exist. You know, there's a translational issue there. But the conceptual idea is that we're always looking at the same data. We're starting digitally to look at time and range, 70 to 180, and then we're looking at level 1 and level 2 hypo and hyperglycemia, as well as glycemic average and a measure of glycemic variability. And that is all present there in the consensus in the AGP report from the International Consensus paper. So talking about time and range, and I could do my whole time on time and range here. This is something that I think is a really exciting topic. There was actually a paper that came out since the time I put this together in Diabetes Care on the consensus for time and range. But this is from about 2 weeks ago, what at the time was the most recent data on time and range. And basically, the reason we look at 70 to 180 right now is because that's the one that all the deeper analyses have been done on. 70 to 180 has been shown to be similar to hemoglobin A1C in a reanalysis of the diabetes control and complications trial data in terms of predicting long-term vascular changes. And so when we talk about this with our patients, we can get in the same conversations with them that we used to get into with hemoglobin A1C, saying, this is valid. We didn't just make up a number. This number has been justified as showing the same risks that hemoglobin A1C shows. And then a separate analysis of that showed us sort of where those targets need to be. This is a paper in Diabetes Science and Technology by Roy Beck showing basically the linear relationship between time and range and hemoglobin A1C. And I like to kind of trace it out to the two numbers we like to use. For peds, 7.5% is about 52% time in target range, and hemoglobin A1C of 7% is 64% time in target range. Now, it's not simple. There's obviously a huge spread there, and that's why we want to go to time and range instead of A1C, because there's spread in both directions. But from a digital health clinic, and Aaron and I were just talking about this, talking about doing patients, not on site who can't get an A1C, they can get a time and range. And so if we can make an analogy between time and range and vascular risk, we can actually skip the need to get hemoglobin A1C. Not all payers will agree to that, probably for a very long time. And you'll get those nasty letters saying that your patients haven't gotten a hemoglobin A1C. But it enables us to still have a practical conversation with the patients about that. The second key that I would say is establishing good clinic flow around device uploading. So at our clinic, the first role happens with the front office staff getting the devices from the patients. So I kind of like to think about responsibilities and barriers. The responsibilities with the front office staff to get the devices from the patients, the barriers to that are, one, patients might not have their devices for 20 to 30 minutes. They're using a pump, that's time they're not getting insulin. If they have a CGM receiver that's not linked to the internet. That's time they can't see their data. The other challenge we encounter with our site is that the office staff is not necessarily trained to ask those kind of questions, and we have a high turnover in office staff. And as we get to perpetually connected devices, this will hopefully not be as necessary in the future. The next responsibility kind of falls with the medical assistants to get that data for us. At our clinic, we have common accounts for all the different companies: Tide Pool, Gluco, Medtronic, Insulet, Tandem, Dexcom, Abbott, to be able to bring that data in. But as we get to kind of uniform uploaders, that challenge will hopefully go away. And there's a lot of barriers to this. In my practice, doing diabetes at many different sites over my career, this has been where the highest level of barrier occurs, because those people need to be highly trained to do that, as well as have the access to the computer systems to do it. If you're not doing it with a common account, then you have to upload from the patient account. Number one problem I've had there is that everyone saves all that stuff in their browser, no one remembers it. And so this becomes an issue of patient training, is making sure that they know to at least have that on their cell phone, so when they come in, they know what their login, their password is, and you don't spend half the visit time with them trying to call their spouse to figure out, is it the dog's name and the girl's birthday, or the girl's name and the dog's birthday? How do you access that data? And then even for people with perpetually connected devices, our clinic is an internet dead zone. Even if they have it on their phone and they haven't uploaded it, I frequently have to spend part of my visit time putting their phone on the network so they can get it uploaded to the network. And these things kind of sound silly and trivial, but all our brilliance means nothing if we can't get the data. And I end up spending probably a third of my time in clinic doing these sorts of things. The next step is the one that I think is most relevant to this audience, is meeting with the diabetes educator. Laurel Messer, who I think was the top right slide in that the Brady Bunch layout of experts there, is working a lot in this area, which is, what does the CDE, in our clinic we have RN and RD CDEs, what does the CDE do with the patients first? And what we're working on now is developing a list of topics that over 1 to 2 years they will work with the patients. So talking about usability, again, if you're not wearing the devices, what we do with them doesn't matter. You have to wear them. And so infusion sets, CGM sites, connectivity, and then aspects of burnout, alarm fatigue, setting right alarms, skin irritation, how to keep the sites on the body. If there's decline in bolusing, behaviors around that, and if all that's pretty smooth, coming up with initial dosing recommendations in discussion with the patient. The two big barriers here are, I think, time to do this, and as the staff is allocated at our clinic, we have 2 new onsets per day on average. So if we're overburdened with new onsets, we might not have the time to do this, but making sure that that's a priority, as well as cost and reimbursement for that time. The next is the billing provider coming in and using the digital data to conduct the visit. And that's what I'm going to go into in the next few slides, is how I do that in our clinics and sort of run the whole visit around that. So to build the visit around communication using the reports. I went through this a little bit earlier, but just to kind of bring the idea back, there's proprietary platforms for many of the systems, and there's also uniform third-party platforms. It's hard to say which one is better. I think, I'd like sort of a Frankenstein's monster of them at some point, some from one, some from the other, but having it be consistent is, I think, going to be the best going forward. So I conduct my whole visit discussing around these reports. There's some people in the room who are probably going to be like, yeah, who doesn't do that? There's some people in the room for whom that hasn't been an option because they don't get the data in real time. And I've definitely heard both as I speak in different places. Here's an example of the Gluco report. Erin's going to be going into a lot more detail on how we can use the reports both from an advisor standpoint and a professional input standpoint, but this gives me most of the data that I want to know just in this one page. How much they're giving for basal and bolus, how much time they have in range, how much hypo, etc. The next graphic that comes through the Gluco reports is kind of an hour-by-hour, point-by-point tracing, but I really liked the smooth data. The bottom picture here with the blue smooth graphic is what I have most of the discussions with patients around. I think a lot of providers are back and forth at this. Do you kind of do a longitudinal flow, or do you look at smooth data? My mindset is we dose based on modal day. We can't dose based on a finely instanced day. So it makes the most sense to try and make the adjustments based on the modal day. And then we get the device settings. And then I usually just write, directly on this with the patient, as we're discussing dosing adjustments, and then put it in the computer for download for them to take home. Then Tidepool presents fairly similar data. Again, there's even differences between Gluco and Tidepool here, but what we see is times in target range, basal bolus breakdown, as well as how often they're bolusing, how often they're giving corrections. And Tidepool presents a little bit different of a smooth graphic. I'd like to see a more smooth one from them in the future, but here we can kind of see broken down by every hour of the day, whether or not they're in target on average for that day, where their low extremes are and where their high extremes are, and get in a very similar conversation with patients as we run through this. And then the device settings that we can use, again, to make those adjustments. So as we talk about the future of this field, I think the first big key in the future in digital clinics is going to be perpetual connectivity, removing those barriers that we have to being able to get the device data. And our hope is that most of that will be in place within the next year. Once the devices are linked and we have access to them, it improves our ability to communicate around them and allows us to have real-time data visualization to be giving advice from new onset phone calls to periodic tuning between clinics. The presence of data in the cloud will also facilitate online review and patients being able to see our reviews and have them pass back to them in a secure way. Such tools have been shown in ongoing studies to be safe and reliable, but I think the real future benefit of this is going to be what Aaron's going to talk to you about, which is our ability to do this without us having to have direct input, but to be able to use artificial intelligence and machine learning to supply these directives to the patient in terms of dosing adjustment with the online data. So Aaron, I'll go ahead and let you take over, and I'll be around after Aaron's done for questions for as long as you guys want to chat with me about diabetes technology, because I love it. It's my favorite thing. Thank you.
Well, good morning again, and thank you very much, Greg, for the presentation. Just wait a few seconds for the slides to come up. Okay, so I don't know how many of you know, it doesn't work. This one, right? Okay, I don't know how many of you know who we are or where we came from. So we are a company originating in Israel. It's a long flight here to Houston. But we didn't start it like that. So what is unique about our company is that we started to work to develop technology as part of Schneider Children's Medical Center in Israel. And I've been working together with Professor Moshe Philip for the past 13.5 years. Most of our work was around creating artificial pancreas algorithms. We published it in New England Journal of Medicine. We're the first group in the world that sent people home with artificial pancreas, getting regulatory approval of that in Europe, and we are part of the 780 algorithm that Medtronic is going to launch, I hope, pretty soon. And also, we are part of a group that were around a lot of the consensus about how to treat patients with insulin pump, how to treat patients with continuous glucose monitoring. And the purpose of this workshop is to share some of our experience with you today. So I'm sure that when you are downloading data and look on CGM and pump data, this is a picture that we see in our clinics a lot. And I think that most of you see those pictures also. And one of the things about this picture is that, wow, what I'm going to do here. The glucose is very hectic. We have lows in nights, lows in the evenings, highs in night, highs in the evenings. What is the problem? Is it because of the basal? Is it the problem of the meals boluses? Is it correction? Is it something that relates to the patient behavioral? And it takes time how to analyze these data and understand. And what I would like to provide you in the next couple of minutes is some tips how to look on this data and how to dive into analysis of CGM and pump data. So here are my tips. So if you want to read this and go out, that's it. That's the whole presentation is going to be about that. So stage number one, like Greg said, let's make sure we have enough data and the data quality is enough in order to make a decision about it. And there's a lot of behind this, what is good quality of data. Then we're going to look on patterns. We're going to look from 3,000 feet of the ground, look on patterns. And only after that, we're going to drill down and see if there is something in the day-to-day. And we'll give you some examples on what each one of these stages means. So first, let's talk about quality data. And to do quality data, in order to have effective patterns analysis of CGM, we need to make sure that, number one, the data is representative. So we're trying to do analysis of the past in order to make some conclusions about the future, right? So we want to know there is no special circumstances happen in the past, because if it has something, it will not be able for us to make a conclusion on the future. For example, if the patient was hospitalized in the past 3 weeks, there is no way to analyze his data right now in order to make any conclusion about how that analysis will affect his future. Then we want to make sure that we have enough data to analyze that. So if, for example, if he didn't wear the CGM enough over the day, so it will be difficult for us to make conclusion over that data. Also to see if there is something special about his patient history that we would like to pay attention while analyzing the data. And again, find if there is any irregularities in the data. So example is the question, how much is enough data in order to make a conclusion? So here are 2 manuscripts published in 2014 and in 2010. One of them is talking about 12 days of CGM data. The other one is talking about minimum of 14 days of data. The consensus that was just published a couple of weeks ago talks about 14 days of CGM data. So we are relying somewhere between 12 to 14 days of CGM and pump data in order to make analysis and get in some sort of a conclusion, what is the glucose control of the patient. Then step number 1 is look on glucose patterns. And when we are looking on glucose patterns, we're usually trying to find 3 things. One is where the patient is stable, where the patient has different excursions of highs and lows, and then if there's anything that it repeats itself. So for example, if we see that every day he has a low around noon time, this is something that we would like to mark for ourselves. If there is something that is, let's say, outlier, okay, one day he got low around 8 a.m. in the morning, usually when we're doing a retrospective data analysis, it's something that we need to talk with the patient, but not something that usually will drive a change in the therapy. We'd like to see some patterns, something that repeats itself. So for example, if we look on this AGP report, we can mark up the things that we are look on. So we looked at, yes, the overall glycemic control is okay, has 134 average glucose levels. It has about 61% time within range, which is pretty much okay, but still he had some highs in around the morning time, evening time, and low in something around noon. So we are just taking the AGP report and make these marks on ourselves so we know that these are the places that we would like to pay attention when we're trying to change something in the therapy, or when we would like to find ways how to help them with the behavior relating to the way the insulin is being delivered. We're also look on the total daily dose and the deviation between basal and bolus. Here we can see that we have a pretty much nice deviation between basal and bolus, and this is something also that we should mark for ourselves for the next step. Then when we're trying to make some questions, so once we mark up the patterns, we're questioning ourselves, what are the reasons for these patterns? So for example, here are some of the reasons that we need to think in the back of our mind when we're trying to find the reason for repetitive hypoglycemia. Is it problem with the basal? Is it something related to the boluses? Maybe there is something that in the interaction between the meal boluses and the correction boluses. Maybe it's a pattern of an exercise. So for example, if we see a constant pattern of hypoglycemia in the afternoon, maybe that's the time when the patient is doing exercise. Or for children, during 10 a.m., usually school break, so we need to put that in our back of our minds. Maybe alcohol consumption could be another reason. Insulin stacking, so the patient just doesn't give enough space between one bolus to the other. Or blind boluses, so for example, he gives boluses without measuring his glucose. All of these are potential possible reasons for repetitive hypoglycemia that we need to consider. Step number 3 will be to drill down. So after we find these patterns, we're trying to look on the day-over-day glucose patterns with the insulin and trying to find the causes for what we saw. And we're trying to evaluate the treatment and the adherence to the treatment. So for example, we'll look on metrics like the number of boluses per day, the time of the meal, pre-meal boluses, was it being delivered before meal, after meal, at meal time, and you can see the entire list here on the slides. And here is a nice example that things that we can learn from the pump bolus calculator. There's a lot of things that the pump bolus calculator information can teach us. So for example, we see this example of a 17-year-old female, 63 kilograms, have about 6 years of type 1 diabetes, using an insulin pump with about 1 unit per kilo per day of her total insulin dose, and she's given about 4 average boluses per day, but still her glucose is still high. And the main reason is why, because yes, 4 is not so great. We maybe prefer to give a little bit more, but it's not that bad. And insulin is supposed to work on the glucose, so what's going on? And these were the information from the pump bolus calculator give us a lot of insight. So for example, if we look on these logbook report for glucose, and it's something that's available in all of the systems, we can see that in a lot of the cases, that patient is using the pump bolus calculator, but it overrides the recommendation of the pump bolus calculator. Basically, if we see the error on the point down, it basically reduces the amount of insulin that the pump bolus calculator is suggesting her to deliver, and that could be the cause why she's delivering boluses, but she's still high. So all of these are informations that we can track from the report. Now, our mission at the end, and I'm sure that you can appreciate that this is very burdensome process for healthcare providers in the very small amount of minutes that you have with your patients to go all of these lists and look on all of these events and remember everything to check in the data. It's very difficult, it's time consuming, it takes a lot of expertise how to do that. And one of the missions that we put on ourselves is how can we help you excel? How can we help you take your attention and be with the patient and talk with the patient instead of this nice figure that was published in MIT research? Most of the time, your faces will be in the screen instead of the patient. Your back will be with the patient. So this is our mission, and I would like to show you how we can help you better performing while you're doing clinic visits, and also do something that Greg is doing in his clinic and other clinics that we visited, maybe do something in a telehealth when a patient pick up the phone and call you. You would like to have some way systematically to go over the data and make sure that you're making the right recommendation for that patient. And that technology, what we called, is the Advisor Pro. And what Advisor Pro is doing is basically reading all of the information that you have in front of you. So the CGM, the SMBG, the pump data, all the features from the pump data, the alerts, the pulse calculator, whatever the pump allows us to read, we're reading it. We're putting it through an algorithm, and what we provide you at the end is one page where you can see the recommendation of the algorithm how to optimize the insulin pump settings of the patient. What's neat about this technology is that we got clearance by the FDA a year ago, basically creating a new product code here in the United States. So we right now the only technology available in the United States that has FDA clearance to analyze CGM and insulin pump data and provide recommendations to healthcare providers how to optimize insulin pump settings. So Advisor Pro right now has accessibility within 2 systems. We are integrated within glucose. So if you have glucose in your clinic, we can basically contact us and we can open just another tab, like lighting a light switch in the room, and you will have another tab within glucose, and you can get access to Advisor. Or if you're working with Typo or with Apple Health, we have our own standalone system that we can give you and work in the clinic. There is no need to install anything on your computers. Everything is a cloud system, so there is no problem of downloading or everything behind that. So in order for you to show you how Advisor is working, I would like to use John as an example. And what I'm going to do is go step by step how the algorithm is working, with the intention to show you that it's exactly the way the stages that I just presented to you. This is the same way the algorithm is working. So here's John. He's about 11 years old with about 7.8 hemoglobin A1C. 6 years of diabetes, and has about 30 units per day delivering insulin, and he comes to your clinic with a complaint of occasional hypoglycemia. So how Advisor will analyze this data? Number one, data quality. So we have implemented a certain amount of safety checks to make sure that when Advisor analyzes the data, it analyzed the data, so I'm sorry, I call it he because like a doctor, but it analyzed the data in the same way that will assure us that we have enough data to make a decision. So number one, we're looking that we have enough CGM readings. We are making sure that we have at least basal and bolus records per day so we can be able to analyze the insulin delivery. that we see enough use of the bolus calculator because we are relying on the current pump settings that the pump provide us. And if there is problem and if the patient doesn't use these pump settings, there is no meaning to analyze this data. And then that the pump settings that is already programmed into the pump are in acceptable range. So we don't want to analyze with an algorithm in order to be safe. We want to make sure that we are not analyzing some extreme patients. So for example, those that have insulin sensitivity factor above 150 or something like that. And if you want to see more information about our safety checks, you just can log into the website and see our user manual in our support page. Then we're looking for patterns. So the algorithm is looking for patterns. And in that quest, we're first looking for stability. So we're looking for the places where this time within range is OK. So we can see that he has about 63% time within range. Yet about hypoglycemia, we're detecting 3 patterns during the day. So we have something in 3 a.m. in the night, something in noontime, and then another hypoglycemia event in around 7, 8 p.m. Then we're looking on the hyperglycemia, and we see that he has hyperglycemia at around midnight, and something after the hypo, so it could be related that before he had a hypo and then he goes back to an hyper, with about 18% above 180. And then when we're looking on the total daily dose and the deviation between basal and boluses, we can see that, oh, sorry, I go back. So we can see that about 62% of his total daily dose is by basal, which is by all the consensus a little bit too much. Then the question that the algorithm asks itself is, what is the causes for the hypoglycemic event throughout the day? If there's anything that relates to the differentiation between basal and bolus, specifically about the hyper around noontime, because this is time where the patient is awake and active, and also what are the causes of the hyper. When advisor is looking on the daily data, like we said, stage number 3, he provides different kind of, it's tried to find the causes for these patterns. For example, we can look on this night, and we can see that the glucose is dropping down through the night, which is a clear indication that if the patient is sleeping and the glucose is dropping, is an indication of something around high basal during the nighttime. And this is something that you see repeatedly over the data. Then you can see that when the patient delivers boluses around 10, 11 a.m., the patient gets into hypo in noontime. So something about the bolus delivery. And another thing that he sees, if you look on the bolus in the slides, so you can see that the mark over here is indicated that the patient override the dose of the bolus calculator recommendation and basically give more insulin than what the pump bolus calculator is providing him. So we also check that that patient is doing override of what the recommendation gave by the pump bolus calculator. And again, we have another event that this exactly same thing is happening. And also he captured event automatically that the patient is eating without delivering any insulin. So these are things that the algorithm can detect automatically from the data, like these 2 events that you see in the screen. So when we ask advisor what to do, these are the formats of the report that he provides us. So number 1, we get a report of how to change the pump settings. On the right-hand side, we can see what are the current pump settings of the patient. On the left-hand side, we can see the recommendations, where all the recommendations are highlighted for you in order to be able to observe them. And also, you have here this edit button. So if you don't like some of the recommendation, you can always edit everything and change it. Everything is editable. On the bottom over here, we can see the personalized diabetes management tips, which are the most important 3 behavioral changes that if the patient will adhere and change it about the way he delivers insulin, it will have the most effect on his glucose control. Then we provide glucose data. So we have 2 reports. One is already implemented, is of course the AGP report that everybody is using right now. And a new report that will be released next week is the logbook report that all of you are aware of from all the other systems. And if we deep dive into the recommendation advisor makes about John specifically, so he overall reduced the basal by 1.35 for the day. And you can see that the reductions are exactly on the times where that patient has hypoglycemia patterns. Then he makes some changes to the meal boluses around between 9:30 a.m. to 3 p.m. Again, it's related to the meal boluses that we saw that the patient afterwards gets into hypoglycemia. And also, we make 2 recommendations about behavioral. Number 1 is to trust the bolus calculator recommendations and avoid override. And number 2, to make sure that he delivers boluses for every a meal and not do missed bolsters, which basically create a lot of variability in the glucose levels. So this is how the algorithm works, and just with a split of a second, you will be able to get all of this information in one report instead of going all of the process of analyzing the data. How do you share the recommendation with your patient? So we have provided 3 ways of doing that. Number 1, we have an app. So once you approve the report, the patient can get it remotely through our Advisor app. Number 2, if he sits in front of you, you can print it or save it in the PDF and just put it as an attachment to your EMR. And number 2, the patient has his own web portal. So once you are approving a recommendation, he can get an email, log into his web portal, and just adjust the pump. Now, as part of our release in the FDA, the regulatory process, we did a lot of usability studies to make sure that patients understand the report of Advisor in order to, by themselves, adjust the pump settings. And what we found is that this is a process that is really understandable by the patient and safe. And this is one of the things that we need to do a check mark before we got an FDA clearance. We did several of clinical trials, and I just don't have the time to go over all the results and the trials, but in your notebooks on the first pages, you have some summary of these studies that you can go over them. Some of them are already published, and if you want to get more understandable about the studies and the results of the studies, you can come to our booth to get more information. What I would say is that the main thing that we checked in the study is if there's any difference between the way expert physician analyze the data and provide recommendations, both from the type of the recommendation and also from an output point of view, to the way that the advisor is doing that. And what we found is that there is a statistical agreement between the way the advisor is providing recommendations and healthcare providers. And also in a small pilot study, we find that there is the same glucose outcome after 3 months of intervention. We just finished 2 weeks ago our multi-center, multinational study that Barbara Davis was part of that study, together with the support of Hemsley Trust and Dexcom and Insulet, where we took 112 patients for 6 months intervention period, randomized them. One group is being treated by healthcare providers that use Advisor. The other one was treated by healthcare providers without Advisor, given recommendation every 3 weeks to optimizing and titrating the insulin pump settings. We're now just collecting the results with the hope to publish them in the next couple of months. So to sum up, Advisor is working for you by allowing you to be more focused in your visit to the patient, by allowing you to do some telemedicine, and also to standardize the way that you are adjusting the therapy. A lot of the clinics approach has said, listen, we have a lot of providers, we're doing satellite clinics. How we would like to make sure that everyone is analyzing the data in the same system, the same process. So Advisor allow you to introduce a standardization to the way your providers in the clinic analyze the data. But using AI is not enough, because like Greg said, we need the data to come to us, right? Because otherwise we cannot implement and influence all of these nice technologies. And we need to be able to implement and assimilate technologies as part of our regular clinic routine. And this is why we launched Advisor Academy last month. And Advisor Academy is basically your first online conference that allows you to learn more about how to implement technology, what are the new things about technology, how to use time in range metrics, for example. So our next lecture are happening in Wednesday, last week of August, by Professor Tadej Batilino, who is the first author of the new time in range consensus that was published a couple of weeks ago. So if you want to be part of this online conference, you can log into our website, register for the live event, or if you don't have time to watch it live, there is no problem. We are providing everything there with videos that you can watch, and even this lecture will be up into our website. So if you have friends that you want to let them hear this lecture, just send them the link and they will be able to watch it. And if you have more questions, our booth is number 1233. We're more than welcome to come to our booth and learn more about the system, see live demo, play with the system a little bit. And we're now open for questions from the crowd if you have. And thank you so much for coming this early in the morning. Thank you again. Yes, if you can come on to the mic, please, so everybody can hear you. There's a mic in the middle. Thank you very much.
Simple question with the apps. So is the Gluco also integrated into your Advisor app or vice versa?
Yes, so we are fully integrated within Gluco, and when the provider approves the recommendation with Gluco, the patient will be able to get it through the Gluco app. So we are fully integrated into Gluco. Whether you have Insulet Provider Gluco or Gluco Enterprise, both of these systems are working with us.
So in your facility where your providers are, the Advisor app, how to get that into Gluco?
So basically what you are doing, you are contacting with us, we are contacting with Gluco, and what you have is that you have the pop tracker, okay? Once you get to the patient page, you have a lot of tabs at the up of the screen, so you will be added another tab called Advisor. All they need you to do is just click on Advisor and that's it, you get the entire report. And if you want, you can see it in our booth, so we have that available there. Any more questions?
I think it's great. I'm just curious the cost of it to the centers.
So it really much depends on the amount of patients per center that use it. And if you want more information, we just need to learn how many patients you have in your clinic and we can send you some numbers. The idea is right now we're trying to penetrate the market, so it's not that expensive, but you have Eldad in the back and he can give you all the information.
Thank you.
Thank you.
I would say though that having worked with it, we find it to be very cost favorable because we're able to save time. I mean, one of our big aims, we haven't gotten to this stage with it yet, but some of our projections about why to work with it are that for the non-billable services, we can actually have less nurse time allocated to them. For all our patients that have new onset tuning between visits or back to school tuning between visits, that when we worked with the Advisor clinically, it saved us a lot of time during the research studies, and that's why we're trying to implement it between visits. And then for in-clinic visits, what I said when I talked about this last year in Germany was it enables us to do more than just be a technician. And I like being a technician, but it enables us to focus on the behavioral changes necessary, to accomplish the text-based recommendations at the end about how to avoid missing boluses, rather than just spend our time coming up with what those things would be. Enables to get us back to being more of clinically focused rather than just technically focused. So I think that it has both financial and indirect benefits to it. And that's what we're implementing it.
Any more questions? Okay, so thank you so much and have a great conference.
Thank you.